Welcome to ACCR. ACCR is an applied graphene solutions company. Today we're going to demystify graphene to make it very simple. There are three things you need to know in order to be able to identify quality graphene. The first is layer count, the second is are defects present in the graphene, and the third is the graphene produced in sufficient quantities to make it commercially viable. For those of you who are not familiar with graphene, we'll start with the basics. Graphene is nothing more than a crystalline allotrope or arrangement of carbon atoms. Please note the two allotropes to the left. You have a diamond, which is a three-dimensional structure, and you have graphene, which is a two-dimensional structure. Please notice that both allotropes are only carbon atoms. There's no oxygen, hydrogen, or other atoms present. Please also notice the hexagon shapes that give each allotrope its strength. So what makes graphene so special? Well, it has exceptional mechanical properties. Its stiffness and tensile strength is 100 times greater than steel. Graphene is actually the most conductive material that humans have ever discovered. Its carrier density is 1 million times that of copper, and its electron mobility is 1,000 times that of silicon. It also means that adding less than 2% of graphene by weight to a material completely transforms the base material. So all the attributes we just mentioned only apply to a single sheet of graphene, as you can see here, one layer thick with a hexagonal shape. As you add more and more layers, these attributes decrease in effectiveness until it becomes graphite. This means that the only difference between graphene and graphite is the number of layers. If you want to work with material that has these amazing attributes, layer count matters. We've found that 1 to 3 layer graphene yields optimal performance. For this reason, we recommend you only purchase graphene from vendors who are willing to disclose the layer count of their materials. Whether or not the material has defects is just as important as layer count. This is because each defect within graphene can negatively impact the effectiveness of the material by an order of magnitude. Multiple defects compound upon each other. To the right here, we have some examples of graphene defects. In the upper left, we have an example of pristine graphene. Notice there's no defects and the hexagonal shape. On the other three images, we have defects that deform the structure. Please notice that the only difference between the pristine graphene and the material with defects is some missing carbon atoms, but those missing atoms are enough to negatively affect the performance of the material. When we say defects, it does not only mean that there are some missing carbon atoms. Defects can also mean that there are function groups or non-carbon atoms present on the material. Here are examples of graphene oxide and reduced graphene oxide. Notice that there are atoms in addition to carbon, being hydrogen and oxygen. These additional atoms change the chemistry and it's no longer graphene. So right now you're probably thinking, why should I even care about graphene? Well, you should care because adding graphene to a countless number of materials can dramatically improve them. So let's start with ballistic armor. When you add graphene to ballistic armor, you could potentially make it lighter and stronger. When you add graphene to batteries, you can increase the charge capacity, the number of charge cycles, and even reduce charging times. Adding graphene to coatings or paint makes them easier to apply, improving their coverage, potentially makes them anti-corrosive or anti-fouling, or even antimicrobial. It also makes them stronger. By adding graphene to concrete, you can increase its compression strength by as much as 50% and increase seepage resistance. For electronics, graphene is actually a superconductor. There's a wide range of electrical applications for graphene because of its exceptional thermal and electrical conductivity. By adding graphene to foams, you can increase its compression strength, flame retardance, stiffness, and insulative properties. Graphene can be added to polymers to hit specific attributes you're looking for, whether that's making it stronger, lighter, more conductive, or other attributes. Lastly, we have resins, where graphene can improve stiffness, strength, and even improve thermal stability. Graphene is not just about making products better, you can also potentially lower their costs. Generally speaking, it takes less than 2% of graphene by weight to completely transform a material. Once graphene has been tuned to a specific material, it should see performance increases from 15 up to 50%. So let's talk about how to get graphene to reduce your material costs. If you add less than 2% of graphene to material, you can get up to a 15% performance increase. What this means is you can use 15% less of your base material, and that should offset the costs of adding graphene. This means that you could make your products lighter and stronger without affecting their cost, or make them less expensive because you require less material. At this point, we've worked with some Fortune 100 companies who have some of the most brilliant material and chemical engineers and scientists in the world, and they have struggled with graphene because they've purchased low-quality material. The only reliable way to characterize or identify graphene's properties is by using TEM or AFM. But these tests cost thousands of dollars, so most customers don't test a vendor's material before using it. Lucky for you, we have a cheat to help you identify the layer count of graphene. So let's talk about scale first. You measure graphene in nanometers. There are 1 million nanometers in a millimeter. You can see this because there are 1,000 micrometers in a millimeter and 1,000 nanometers in a micrometer. A single sheet of graphene, also known as a monolayer graphene, is the height of a carbon atom, which is 1/3 of a nanometer in height approximately. The spacing between two layers of graphene is approximately 0.4 nanometers. If you have two-layer material, also known as bilayer graphene, that material height should be approximately 1.06 nanometers. That's because, as we've mentioned, a single sheet is about 1/3 of a nanometer. The spacing in between is 0.4 nanometers, approximately, and another sheet is 0.3, giving us a total of approximately 1.06. If you're evaluating three-layer graphene, also known as tri-layer graphene, you'll notice that the particle thickness should be the two-layer graphene plus an additional spacing and another layer of graphene. So your total then becomes a sheet of graphene, the spacing, another sheet of graphene, the spacing, and finally a third sheet of graphene, giving you a total of approximately 1.79 nanometers. This goes on until you reach the point that your graphene is now graphite. This cheat helps you approximately identify layer count, but it doesn't take into account defects, and testing is required to identify if material has defects or not. Because material thickness is the best way to guesstimate layer count, we absolutely recommend running from any vendor who will not tell you their material's thickness. At ACCR, we use and sell a graphene powder that is made up of graphene nanoplatelets or flakes. Our graphene powder has the material thickness we just discussed. 40% of our material is monolayer or one-layer nanosheets, 33% of our material is bilayer or two-layer nanosheets, and 14% of our material is tri-layer or three-layer nanosheets. The remaining 13% is between 4 to 7 layer graphene. Our graphene is available in 4 different types based upon the diameter of the flakes. You'll want different diameters for different material application. We currently are able to produce greater than 120 tons of graphene per month, making it viable for any commercial application. For more information, please visit theaccr.com.